Hello everybody, I'd like to welcome you very warmly to the Old Church Centre. Thank you for coming down, thank you for your confidence in our COVID security measures and for your cooperation. Also, I want to say hello to the people who are watching us because this is our surprise. We're being live streamed tonight. It's the first time we've ever done this, and we think there are at least half a dozen people out there with us, so hello to them too. Well, if you're feeling nice and comfortable in this building, not too warm and not too cold, that is in part thanks to our speaker. Tony Traill was the person who came down about 13 years ago maybe and did a green energy survey for this building when it was derelict, and he recommended an air sourced heat pump with underfloor heating, and that's exactly what we've got. So that's what's keeping the building comfortable at the moment. Tony is a director with a company called Element Consultants. Now, it's a coincidence that Elements is the name of this series of talks. There are 4 of them. We had Patrick, who's here, speaking a fortnight ago about earth. Tony's talking tonight about water, and then we will have speakers about air and fire before the end of October. When we decided to organise this series, Tony was one of the first people that was enthusiastic about it, and he volunteered at a very early stage to give one of the talks. We're delighted to have him here. His company's expertise is in saving water, saving energy and reducing waste. He has worked for a long time in that field, and he has particular experience in the glens, which I think he's going to tell you about later as well, with the potential for micro hydro. It's a very big subject, so I will shut up and let him get on with telling you about it. Thank you.
Hi there. So I don't need to introduce myself because I've just been introduced. I volunteered very early for this because I think it's a great opportunity to hopefully educate people. I'm sure you don't need educating, but about water in Northern Ireland. Because if you live here as a private person and you don't have a meter on your house, then you know that you pay for your water through your rates. And I'm going to put it right out there at the beginning that I think paying for water through rates is a really bad idea, because you don't feel the pain of what it costs if you leave it running. You don't know how much it costs. You're not engaged with it. I'm just going to crack on that. I could be here for quite a while because I've got quite a lot to cover. I'm trying to cover where our water comes from, what we do to it, how we dispose of it, how we treat it when we dispose of it, and then a bit about energy at the end. And I have to declare an interest, obviously, because I'm interested in efficiency. I'm probably going to batter on about water efficiency. We all get a lot told to us at the moment about energy efficiency and about carbon emissions, and I think water is under-mentioned in that sphere, because as you'll see that it has a huge effect on carbon emissions and energy. So this is what we all think of when we think of water. Lovely, clean, beautiful water. But this is what I usually think of when I think of water. And it's not terribly clear, but basically it's a filthy shark. And that's the bit that I'm interested in, because this is out there pretty much everywhere you go. You only have to walk around a corner and there'll be another dirty field with pollution down the side of it. And it's something that we need to sort out. So water is a finite resource. There is a limited amount of it on the planet, and there is a very limited amount of it that we can actually drink, that is readily available for us to use. So it is important that we save it. We also expend an awful lot of energy and a lot of money on getting the water around the system. We spend an awful lot of energy and an awful lot of money on treating the water when it's coming out of the system. Actually, we spend a lot more treating it. So we need to reduce those things because they're tied to carbon emissions. Tied to carbon emissions. And obviously, it's all about protecting the environment. Some of you may have heard of the water hierarchy, and this is what people talk about when they start talking about water efficiency. This is more of a commercial slide, but really what we're saying is, it's mostly common sense. Minimise the amount that you use at the front end. I actually don't believe that the alternative water use should be where it is on that slide, so I'll come back to that in a minute. Once we've eliminated everything, then reduce as much as possible, then reuse anything we can, then recycling, which is more on the commercial scale, and finally dispose of as little as possible. So I mentioned alternative water use. I think that should be right down there, because I think it takes away from the fact that we should be minimising before we start to think of alternatives, and I'll come on to that in a minute. You probably all remember the water cycle from school, but it's just to remind us where the water comes from. So it comes from the sea to the sky, and then from the rain to the ground, and from ground to rivers, but also, very importantly, it goes underground. And then we have evaporation and transpiration back to the sky, and then water running down the rivers and coming back to the sea again. And that's the water cycle as it travels around. And of course, we interrupt it on the way, use it, pollute it, chuck it out there again, treat it, mostly. So what happens when the water hits the ground? We get runoff. And most of the water that we use is from runoff. So you can see that in the countryside, 10% of the water ends up as runoff. In urban areas, 55% ends up as runoff. And then we wonder why we get flooding. But also importantly, if you look at the infiltration, we get 50% infiltration in the countryside and about 15% when we're in towns. So anywhere that's urban, we're reducing the available water that is coming to us. Okay, so water sources. We all immediately think of the first one, which is mains water. And that obviously is water that has had to be treated and moved before it gets to us. We don't often think of borehole or borewell water unless we've had experience of it, but we actually use a lot of water from aquifers under the ground. So this is water that sits generally in bedrock aquifers, although you can take it from what are called superficial aquifers as well. And we'll come on to a bit more about that later. Then there's rainwater. And rainwater harvesting is a big opportunity for reducing a lot of the water that we use. We don't do very much of it. Believe it or not, there is an incentive, which I'll mention later. But even simple things like water butts in the garden, instead of using mains water, can make it a huge difference. Reused and recycled water, so we'll talk about that a bit more, but there's not that much you can do in terms of recycling at home, although you can do it in commercial settings. And then there's surface and seawater, which you'll know of happening abroad, but not really here. So those are really our main water sources. So what about here particularly? Where does the water come from here? Well, you can probably see there, but the water for here all originates up on the Garum Plateau in the Garum Blanket Bog. And your water here, I'm sure some of you will remember, used to be probably quite peaty when you got it, a bit discoloured, because the Blanket Bog had been drained, and so it wasn't doing the filtering that it needed to do. And big pat on Northern Ireland Water's back with the RSPB. They restored about 2,000 hectares of the Garum Plateau, so that it now filters the water much, much better, and they have to spend a lot less time and energy cleaning it before it comes down to the dam where it's treated, and then it goes on down to feed most of the glens and a big chunk of Ballymena and Brashane as well. So that's where all your mains water in this area comes from. It's local, which is a good thing. Then the other water sources I mentioned main water source that we have in Northern Ireland is borehole or borewell water. And this is a typical borehole. You've got a bit of overburden soil at the surface, then you get through a bit of subsoil, and you get through to what's called the superficial layer, which is where you tend to have gravels, sands, and those are generally gravels and sands that have been deposited in the ice age by retreating glaciers, so they cover quite wide areas, and they can be quite deep. And then once you get down below those, you get eventually down to bedrock. In between you might have layers of clay, glacial till, and down at the bottom you're into bedrock, and some of our most important aquifers in Northern Ireland are bedrock aquifers, particularly in the Belfast-Lisburn area. So just in case you thought that we didn't use that much borehole water, all of the water used in the Ulster Hospital comes from a borehole. And they are currently licensed to abstract 432 metres cubed per day. They could actually abstract up to 3,500 metres cubed per day. So it's a massive sandstone area which really runs down from Belfast over to the Newtonards Hills and then down to Lisburn. And when you go and buy your fizzy bottled water, there's a particular make that is made by a well-known fizzy drink manufacturer that is sold in Northern Ireland. And all of that water is abstracted from that aquifer, and it's then pumped about, I think it's about 12 kilometres to their new factory, where it is simply filtered or carbonated and put straight into the bottles. So that's where all of that well-known brand of fizzy water comes from. Borehole water is important in Northern Ireland, and it's a good resource. Even in some of our basalt aquifers, it's still possible to get a good abstraction rate. So what do we use water for? Well, we've effectively got potable and non-potable uses. So potable means it's safe to drink. Typically, mains and borehole water are treated as potable. Actually, you probably think of them as different, but they are both treated before they get to us, and they're both inspected regularly by the Drinking Water Inspectorate, which is part of the Northern Ireland Environment Agency, and they have to meet stringent legal standards. I say they have to, they're meant to meet it all the time. Occasionally things go a little awry, and occasionally they just miss it, but generally not by much. And then non-potable water is really everything else. So grey water is water that you typically get from, that's used shower water and used bath water. And black water is the really nasty stuff that no one likes to think about very much. Some of which, obviously, maybe not the black water, can be used for flushing loos, washing machines, washing machine use you can use, that sort of thing. So there are uses, but those are really the main things that the main different types of water that we have. So the next thing that probably most of us don't think about is that a lot of the water that we use nearly all of the water that we use is processed in one way or another. I know that word process is not very nice, but we process it in order to make it potable. We process it in order to make it hot or cold. And we process it by using energy to get it to the places that we need to use it and to get enough pressure in places that we need to use it. And all of those things add value to the water, but they also add cost, and they also add carbon emissions. So the one we obviously think about very quickly is to get your water to come out of your tap, it's got to be pumped there. So to get a flow, you've got to pump it round, the pumps are electric, and we're moving at big distances. We don't have the topography that they have in somewhere like Scotland, so we tend to use a lot of energy pumping the water around the network. Interestingly, we also have the longest length of pipe work per head of population anywhere in the UK. I think that's the right way around. So we have to use more energy getting around. Heating, I mean, obviously, all the hot water that you use in the house, every time you shower, every time you have a bath, every time you wash anything up, domestically, you've got to get it to about 65 degrees to be able to make sure you're not Legionella affected in any way. And if you're using it commercially, quite often it's steam, in which case it's getting it right up to 100 degrees. There's a lot of energy involved in getting the temperature. Cooling, obviously we're chilling and freezing things all the time, and even in offices they have these mobile chillers which are constantly using energy all the time just to keep it cool to sit there. A waste, if you ask me, but there we go. Pressurizing, we probably don't think of that one so much, but obviously if you turn on all the taps at home at the same time, it's going to reduce the amount of pressure, so you've got to pump it even more to give you the pressure to get an even flow around the house. So all of those things add value, add cost, and add carbon emissions. You can sort of see where I'm going there. Oh, and the last thing, of course, treating. Chemical and physical treatment, so we're treating it on the way in before we get to drink it in order to make sure it's clean. That could be various types of different types of treatment, but anyway, it's treated on the way in, and then there's a large amount of treatment on the way out, because obviously it requires work. This is the fun bit. Disposing of wastewater. We all probably know about our domestic foul wastewater, and there are really two ways that can go. If you're on the main sewer, it goes into the main sewer and it goes to the main sewage treatment work that serves your area, where it's treated, and then, surprisingly enough, out it comes, and it goes back out into the environment again. If you're not on the main sewer, then you'll either have a septic tank or a packaged sewage treatment plant, and that will do the same thing again that the main treatment thing does, so it will get it down to a standard that's acceptable by the NIEA before it goes out into the environment again. You can sort of see where I'm going with this, can't you? Then if you're a commercial operation, you could have, you'll have what's called foul water, and you'll have trade effluent. So anything, it's quite tricky trade effluent, but basically anything that's used in a process, water that's used in a process and then comes out the other end, is treated as trade effluent, and it's treated differently from foul sewage when it comes to the price and how it's treated and that sort of thing, and who controls it. Basically, if it's going to a main sewer, it's controlled by Northern Ireland Water, and the business will be given a discharge consent, which gives them the limits that trade effluent has got to meet. So it will tell them whether it's allowed to have any fats, oils and greases in it, whether it's allowed to have any ammonia, what levels of biological oxygen demand and suspended solids, and they've got to treat their water down to that level before it can then be put into the main sewer system, so that it doesn't upset the main treatment system down the line, so that it in turn doesn't start spilling sewage that doesn't meet the environmental standards into the watercourse or wherever it's going at the end. And then the other type is a discharge straight into the environment of trade effluents, in which case that is licensed by the Environment Agency, and they set the standards for that it has to reach before it gets disposed to a watercourse. Then the third one, which we probably don't think about that much, is what's called stormwater, which is just all that water that runs off. Where does it go? Well, actually, these days it will either normally go into a stormwater drain, which goes to, in the countryside, most places have soakaways, so they're basically gravel pits that your rainwater goes to and then just infiltrates. If it's in a town, it will normally go to, if it's a modern sewerage system, and that modern sewerage system is available, it will go to the stormwater, specific stormwater drain. But the tricky bit is that a lot of our older sewage systems are actually what are called combined drains. So they take not only the foul sewage coming out, but they also receive the rainwater runoff. So you can just imagine every time you get, you may have heard of the Thames Tideway project, which is this enormous ring sewer that they're building in London. And it's a massive engineering project, huge tunnel to join, goes round by the Thames, can't remember exactly where it is. But basically that is in order to alleviate the problem that they have, that is every time they have a really heavy rainfall or prolonged rainfall, that water's got to go somewhere. And all of these treatment places and sewage holding systems have got effectively a weir, and when it hits that weir, it just spills out into the Thames. So this is to try and stop raw sewage being spilled into the Thames. But we have the same systems here in older sewage systems where, if you get heavy rainfall and it goes down that same sewer, it's going to end up at the treatment plant, and the treatment plant will have a limit, and I'll explain a bit more about that later on if I don't bore you too much. And that means they cannot control that inrush of dirty water, which makes it very difficult for them to treat it to the necessary environmental standards. Sorry, I went on a bit there. The main point is everything ends up in the environment. Okay, so quick summary of that. Water efficiency saves money, cuts carbon emissions, protects the environment, and greens the supply chain. If we use the water hierarchy with mindful adjustment, that's a really good way of addressing it all. Water sources cost money, water use costs money, water disposal costs money, and they all produce carbon emissions. So save water, save money, save the planet. Okay, now we're getting into the boring bit, which is the maths. Yes, we're getting into the maths. Most of you won't know this unless you run a business or you have your own meter on your water. But every cubic metre of mains water that comes into your building and is used costs £1.09 per cubic metre. And that's without any of the standing charges or other charges that might get attached to it. And a cubic metre, you can imagine it, it's not that big, it doesn't take long to use a cubic metre. So £1.09 plus the standing charge. If you're using borehole water, you've got your pumping costs, your treatment costs, there'll be a licence cost. If it's commercial, probably a licence cost. If it's domestic, maybe not. Rainwater harvesting, again, you've got costs, you've got pumping and you've got treatment. Nearly all of these things, there are costs involved. But just bear in mind that mains water cost, because we're going to work on that. So if you take a 1-inch hose, at a typical mains water pressure of just under 1.5 bar, and the flow rate through a 25mm orifice at 1.47 bar is 5.8 metres cubed per hour, that's going to cost you £6.32 an hour. So if you leave a hose running, just an inch hose, for an hour by mistake, £6.32. That's what it costs at the moment. And the prices are likely to go up. Okay, so there's a bit of maths here. This is heating water, and it's just the standard formula for heating water, and the column on the left on the far side gives you the cost for heating water to 65. This is using gas at about 4p a kilowatt hour. Everyone happy about kilowatt hours? This is how they measure your electricity, it's just a measure of energy. Anyway, using to 65 degrees, using 4p per kilowatt hour for gas, £2.60 a cubic metre just to heat your water to 65 degrees. The one on the right is heating it to 100 degrees, which is sort of a steam calculation, but it's not, because there's lots of other things that are involved in that. It will be more. So that's £4.25 a cubic metre heating steam to 100 degrees. Okay, dirty water out. Main sewage, £1.82 a cubic metre. Trade effluent, now it's a bit complicated. Trade effluent is calculated using an exciting formula called the Mogden formula. And the Mogden formula adds together it uses a whole load of things, but it basically works out how much it costs depending on the strength of the sewage, based on the suspended solids, so that's all the mucky stuff floating around in there, and the biological oxygen demand. Biological oxygen demand, really quickly, you've probably all seen pictures of dead fish floating in rivers at some stage, yes? So when you see a pollution incident, that is because organic matter has been flushed into that river, and the organic matter has a biological oxygen demand. It sucks the oxygen out of the water. The bacteria suck the oxygen out to be able to do their magic. And when you get a fish kill, usually, not always, unless it's a chemical fish kill, it is because organic matter has been flushed into a river. That organic matter, the bacteria in that, have sucked the oxygen out, so these are aerobic bacteria, in order to do what they do, and that has been meant that it means there isn't enough oxygen for quite often the plants as well, but certainly the bigger fish to be able to go on breeding. So BOD is a measure of how strong sewage is, because obviously in order to be able to put it back into the environment, you need to address the BOD to be able to get it low enough so that it doesn't have an impact when it goes back out into the environment. Okay, yes, so there's all these costs involved in the sewage side, but basically the main thing is it is much more expensive, obviously, treating the sewage on the way out than it is treating the water on the way in to make it potable. Oh, take a 1-inch hose again. At 1.5 bar roughly, flow rate, same flow rate, £10.55 per hour for sewage and £4.64 for standard strength trade effluent. So, mains water in plus 65-degree heat plus main sewerage, £19.48 per cubic metre. And that reflects what it costs Northern Ireland Water to do the job. So once you think about it in cubic metre, 20 quid basically. Water is expensive and sewage is expensive, and the reason it's expensive is because of what we have to do to be able to use it, and all of those things pretty much have carbon emissions attached. Yeah, there we go. Every drop costs money at least twice. Carbon emissions. Okay, so it's quite tricky doing carbon emissions with water, because if you can imagine that there's a massive infrastructure. They are busy with these massive pumping stations in order to move water around. They're then busy treating it like your treatment plant up here on the top of the Garran Plateau, so that you can have clean water coming to you. But the big treatment is on the way out, is dealing with the wastewater, because it has to be pretty much, it has to be aerobically digested. So that means you've got to get air into the wastewater, oxygen into the wastewater for the aerobic bacteria. So if you think about it, you've all heard of anaerobic digestion plants, maybe, producing gas and electricity. They're anaerobic, so they don't have any air in there, and the result of that anaerobic digestion is that they produce these gases. The main one is methane. We call it biogas, and everyone says it's a good thing because it can be used to produce energy and deal with our energy problem, but it produces these biogases, which include methane, hydrogen sulfide, and sulfur dioxide. And you may also have heard of farmers who have lost their lives when they've gone down into slurry tanks. Tragedies that we have in Northern Ireland, and that is because the slurry forms a crust when it's in the tank. Underneath that you have, if it's not aerated, it's just sitting there, you get anaerobic digestion, and you get exactly the same thing. You get methane, hydrogen sulfide, and sulfur dioxide. Sulfur dioxide smelly, but the methane and the hydrogen sulfide, particularly the hydrogen sulfide, are colourless and clear and heavier than air, so you break the crust, the gas escapes, you don't smell it, you haven't got a hope. But that is exactly the same thing that will happen when we treat our wastewater. We need to stop it being anaerobic to avoid those emissions, and therefore we have to get air into the wastewater for the aerobic digestion to take place, which just produces water and oxygen. I think maybe a bit of hydrogen. Anyway, so we have to get air in there. And the only way we can do that really is by pumping the air in, and that means using compressors. And compressors, give you a very little fact, up to 90% of the energy used in a compressor is turned to heat. Only a very small proportion goes into the energy of getting this air compressed and into the compressed air basin, the aeration basin, to be able to treat the water. So there's a massive amount of energy involved in that. Anyway, so huge carbon dioxide emissions. Yes, what is it? 90,364 tonnes of CO2 equivalent, so that's greenhouse gases, in 2018-19. As far as I'm aware, so this has come from the Northern Ireland Water report for 2018-19, and as far as I'm aware, the first figure, the 0.118, is treated water coming in, and the second figure, 0.386, is obviously the treated used water going out. Scotland have much lower figures, but then Scotland have this wonderful advantage of gravity, so they're not having to pump stuff everywhere. Northern Ireland Water is the biggest consumer of electricity in Northern Ireland. So that's, that fact alone tells you how many carbon emissions are involved in this process. Okay. They also use it obviously for heating, a bit of heating, pumps and fuel, and in the water treatment plant, pumps, motors, treatment, tank and waste, they all use it. Carbon emission example, right. Sorry, more maths. But we've got the 118 at the top, which is the water in, the 386 next, which is the sewage out. If we took a volume of 21 metres cubed, yes, sorry, this was an earlier maths I did, so it's a random volume. You could use 1, you could use 7. We'll take 21 metres cubed. A typical Northern Ireland person uses 150 litres of water per day. That's right, which I think is 55 metres cubed a year. So this is half a person's use per year, roughly. Combine it, 10.67 kilograms of CO2e, add that gas, add it all up, 288.42 kilograms of CO2e in 21 metres cubed. So, and that's not all. Carbon emissions from Golf GTI 5-door DR, sporty Golf, 143 grams per kilometre. So 15,000 kilometres, 2,145 grams. So 1 hour of hot water is 2,000 kilometres in a Golf GTI. That's the carbon emissions. You then get your head around the carbon emissions. Yeah, I won't spend too much time. In case I've got maths a bit wrong, I won't spend any longer on that.
What's the cost of a person per year? Do you know that?
I haven't got it in front of me. I could probably work it out pretty quickly because it's 55 cubic meters, and there is a figure for the rough amount of hot water you use. It's actually not far off 50% hot to cold, but it also then depends on the type of fuel that you're using to heat your water, and also where you're getting it from. So, for example, if you were using electricity to heat your hot water, and you were getting it from one of the, I mustn't be specific, one of the producers who is less carbon efficient in Northern Ireland, then it's a massive figure. It's more than twice the gas figure actually for 2018. It's coming. It's another. Let's do that one at the end. Hold that thought. Water costs money and energy. Dirty water costs more money and energy. Hot water costs even more money and energy. A small amount of waste adds up to a large amount of cost and emissions over time. Wasting water increases carbon emissions and accelerates climate change. Save water, save money, save the planet. Okay, so this is coming back to the water hierarchy. This is what we can do. Northern Ireland Annual Water Report 2019-20, we use 70% more water today than we did 40 years ago. So we're an awful lot cleaner, but that's a heck of a lot of water. And that's probably because we don't have to go to the hand pump to get it up from the bottom of the well, to bring it in, to carry it in. It's extraordinary how little water you use if you've got to make an effort to get it. It's also extraordinary how much less water you use if you have to pay for the water at what it costs. Yes, the average person could reduce their water usage by around 40% and Northern Ireland's total water demand by 25%. It's interesting, that's a little fact there. So we could reduce our total water demand by Northern Ireland's total water demand by 25%. That actually is the equivalent to the amount of water that Northern Ireland lose each year through leakage. And that's one of the problems with having an enormously long pipe system. So these are the things you can do, and we quickly covered that earlier, so I'm not going to spend hours on it. But I'm going to give you a quick idea of what the commercial side of this is like. First thing you need to do, if you're going to do anything about saving water, is understand where your water goes. And this is a water map for a job I did for a company, I can't remember which one, which shows their mains water coming in, where it goes, they've got a big sprinkler system, they've got a big cold water storage tank, and it goes to various different things: canteen, toilets, tub wash, pressure washer, comes down through various processes, and then it goes to different places. So you've got stuff that doesn't go back to the sewer, that's non-return to sewer and makes up part of their non-return to sewer allowance, which they don't have to pay for. And that includes water that evaporates, obviously. So if they're using steam, there'll be evaporation. It's water that goes into product. For a food manufacturer, obviously water will go into product. Then there's trade effluent, which is the water that goes through a process. So here's a tub wash. So that's for, obviously this is for washing out equipment in a food processing place. So that is a trade operation, so it gets treated as trade effluent. And then at the bottom we've got foul sewage, which is the stuff that comes from the canteen and the toilets, although they do get a bit of non-return to sewer allowance on that as well. All those little coloured dots are either existing meters or where we've suggested they put meters so that they can understand where their water goes. Because how the water goes out affects how much it costs them. And also, they can't possibly really understand how they can reduce the cost of all of this if they don't know where the water's going. And, more important than anything else, where they're losing it. Because water has to go somewhere. So if you've got meters in the right places on the system, you can see where the water's coming in, but it's not going out, which means you've got a leak. And there are leaks in every system. Okay, this is a bit boring, but this is what's called a water mass balance. So this is the bit we were talking about. Once you've got all your meters, then you can measure what's coming in, measure where it's going to, measure where it's going to next, and you can work out where you've got losses. There aren't any losses on this because they don't have enough meters to work out where the losses are, because they didn't when you did the job. But it does give them an idea of where it's coming in, where it's being used, and the different places that it's going out. And they need to know all of that because if, for example, they've got a combined sewer on part of it, they've got storm water, so every time it rains, the water's coming in and going on their trade effluent or on their foul sewage, and they're paying for that. So, understanding. So from a domestic point of view, it's a similar thing. You need to try and understand what you use and where you use it. And all I'm going to put, here we are, 150 litres per person, daily average in the UK, 55 metres cubed per year per person. So that's a big volume of water. And the big figure there, toilet, 30%. Baths and taps, 21%. Showers, 12%. So those three big areas that we can do things about straight away. Okay, so eliminate non-essential use. Come to presentations like this so you understand what you're doing. So educate. If you're in business, obviously, just have a turn it off campaign. Go around turning things off. You're not allowed to hit people over the head with anything anymore, but berate people for not turning off stuff when it's not being used, because that is the biggest loss of everything. People go off on a tea break, hose is left switched on, don't think twice about it. And probably because they don't have any idea of what it costs. Because they don't pay for it at home, they don't understand what it costs, they don't understand what it costs for the business either. Staff suggestions, reporting procedure, try and involve people in your business down through the chain, appoint someone to manage it, get people involved, receive ideas. If you save money, maybe do an incentive scheme where you can't take them all out at the moment, but the pubs are going to be opening shortly, so you'll be able to do that. And then preventive maintenance is really the main thing. Just regularly checking for leaks, fixing them, and doing it properly. Oh yeah, why are leaks so important commercially? I think I mentioned it briefly. Oh, hang on. Why isn't that doing that? I'm pressing the wrong one. Maybe I've lost that bit. Yes, I've lost that bit. Leaks are so important commercially because of the way that the cost is calculated. So if you are getting water in from the mains and it's being metered, then you are going to pay for that water going out. And if you have a leak, then because of the way they calculate it, unless your outflow is metered, you are going to pay for all of that water coming out, going in and coming out. So you've got the most expensive charge is the sewage charge, and if it's not being accounted for in your trade effluent and it's not being accounted for in your non-returned sewer allowance, then if you've got a leak, that water will be treated as sewage, and you will be paying £1.83 per cubic metre for the water that is going out in that leak. Okay, oh yes, this bit. And just to, I know that the slide hasn't come up terribly well, I don't know if you can see it or not, but can you see the leak? You see that? This is the leak. And it's from that pipe, and it's an overflowing system from a toilet. And if you go around the back of pretty much any hotel or any business to where the toilet block is, there's almost always a stain like that on the wall, where it may have been fixed, but it's one, and that is running, because if the ball cock is faulty, that is running 24 hours a day. Okay, so if you're in a commercial environment, you need to establish your base consumption, which doesn't cost you anything to do apart from a bit of time internally, maybe adding meters, but meters aren't very expensive for water, depending on the size of the pipe. Once you've got that established, you can establish key performance indicators and benchmarks. So key performance indicators, typically you'll be saying, I produce 5 million widgets a year, therefore this is the amount of water I use, therefore I use X amount of water per widget produced. And that then gives you a measurement that you can try to drive down. And you just keep doing your monitoring and targeting and keep trying to push that figure down. And if it's going up, there's a problem. So, and then benchmark is, if you can get hold of them, figures from, generally figures from other companies in your same industry, and normally there are benchmarks produced by quite a lot of people like CIBSE, Chartered Industry of Building Services Engineers. They'll produce benchmarks that you can use. How am I doing for time? Wittering a lot. Come on, press the wrong button. There we are. Can you see the leak on that one? I took a wander up my road, and actually it was last winter, and I heard a trickling sound. And there through the hedge was a trough for some catwater in the field, and you probably can't see it, but there is a leak. And that leak was still there a week later. Didn't know who the farmer was. But that's probably, that's full mains pressure, it's a good flow, maybe a litre a minute, just bang, bang, bang. Right, alternatives, yes, so this is lower down my hierarchy list, but there we are. So Borewell water, very low incoming cost, because when you abstract water from the ground, it's licensed by the Environment Agency, and you apply for the amounts that you want to try and abstract based on your borehole characteristics and the water features in the area, and they will license you a certain amount. And if you extract less than 100 meters cubed per day, you pay nothing. So that's a lot of water during the year, and for a business that's very valuable. There is an argument to say, I think, that you should be paying more for that water, but that's just my point of view. I'm happy to discuss that later. Rainwater, again, low costs, and believe it or not, there's an incentive in that if you put in rainwater harvesting, your sewerage cost will be reduced from £1.82 to £1.13 for each metre cubed that you put in. And actually, there are rainwater harvesting systems that you can get that are actually not that expensive, even on a domestic level. But yes, initial capital costs, borehole developments, pretty expensive, especially when you get to the big sizes of things. But the payback is very quick if the water is cheap. Doesn't save you anything on the way out. So reduction. Efficient domestic fittings, lovely word, urinal control, or indeed, so that's urinal control. Typically, if you're a gentleman and you walk into the lavatory and it's got urinals, then the older type of systems are what are called fill and flush. So there's a ball cock and it just comes up and just empties and up, empties and just fills as quickly as it's turned down on the machine. Nowadays they have PIR recognition and solenoid valves which control what's going in the flush. Better still, waterless urinals. So those of you who may have frequented famous hamburger joints may have used the lavatories, and some of the best known names have all got waterless urinals right the way through. And in fact, some really good hotels are now fitting waterless urinals in their public lavatories, which is a really good idea because it's a massive saving. Taps, flow and duration. So really simple. This is all about minimizing the amount of water that comes out of your tap so that it's what you need. And typically for a hand basin, 3.5 litres per minute, which is an awful lot less than most of you will have. And for a kitchen or utility room, 5 to 8 litres per minute. In fact, 5 litres per minute is fine in a domestic setting. 8 litres per minute maybe in a commercial kitchen. And those can be easily done. In fact, on most of your domestic systems, if they were done in the last 20 years, 10 years, they've probably got little valves on the feed pipes, or if your kitchen's been changed, they'll have little valves on the pipes coming up the taps, normally baller fix valves or lever valves, and you can just turn them down until you get the flow low enough. Yes, all of that ILF are inline flow restrictors, which are little valves which control the flow. You just fit them to the pipe. Aerators probably, yeah, they're okay. They fit in the end of your tap. Quite a lot of taps these days, most taps these days actually come with flow control if you buy a new tap. And push taps in a commercial setting. PIR, good in some places. Just be aware if you're running a business, if you put in PIR taps, if your staff wear high-vis jackets, you really don't want them. If the PIR is mounted vertically on the tap, as you walk past the tap, every single tap will go off because they get set off by high visibility jackets. Yep, I found that one out by mistake. Showers. So I'll skip electric for a second. Low flow, that's about aerators and inline flow restrictors. Aerators, you kind of have to test a shower before you commit to buying it, because if you aerate the water coming out of a shower, you're effectively adding cold air to warm water, and that can reduce the temperature of the water by the time it hits your body. And so if you've got a modern system which has got a mixing valve to make sure that your water temperature coming to your shower cannot scald you, it will drop that temperature even more, and it can affect your enjoyment of the shower. Inline flow restrictor is good. You're looking for about 8 litres per minute. So none of those big power shower type things which can use more than the bath if you stay in it for 5 minutes. Electric showers are really good because they have built-in flow restrictors in order to be able to heat the water high enough, and by and large the experience is good, and they reduce the amount of water you use. They're really pretty good. Where are we going next? Oh yeah, WCs. If you've got the old type of WC, then it's the old brick in the cistern job, which you probably all remember, but actually you can buy a thing, there are various what are called cistern volume reducers on the marketplace. Just Google cistern volume reducers and you can get them. There's a really good site, one particular make, which I better not say, and they have photographs of all the different types of cisterns, so you can recognise the type of cistern you have and then get the correct bag to fit in that cistern. Low flush, twin flush. You have to be quite careful with twin flush because they can be quite confusing. And you can look at a twin flush and go, well, which button do I press? Unless it's really obvious. So you have to be careful with those. Anyway, moving on swiftly, wrong button. Oh yeah, the study for the electric showers identified the customers with a mix. So this is a study that was done by United Utilities in 2007. I know it's a bit old now. The customers with a mixer or pump shower operated over 8 litres a minute can enjoy a financial payback within a few months from installing a water-saving shower head that does not impair customer satisfaction. So you can do it. Okay, commercial fittings. There's a lot more you can do. Process flow control, fitting interlocks, limit switches, making sure that the default position is off. So it's something we do with a lot of machinery for energy saving, but basically it means that when the guy comes to turn the machine, it opens the valve that allows the water to flow. Until he turns the machine on, the water cannot flow. That way, nothing is wasted. Nozzles and sprays, there's a lot of cleaning down being done out there in commercial premises, particularly food manufacturing, and typically people will go and buy the cost-effective spray head or the one that the rep is selling you. But actually, nozzles and spray patterns is a complete science, and they have specific nozzles for specific spray patterns and flow rates. And if you have a situation where you're washing things down, you should test them all so that you get the right thing for the job that you are doing, so that you're using the minimum amount of water. Yeah, take advice from the manufacturer of the kit as well. VSDs, variable speed drives. So these are also known as inverters, and this is for controlling an electric motor. And what a variable speed drive or inverter can do is it can control voltage, frequency. Basically, it can respond to the activity that you're doing, so that if the amount of water that you need or the pressure you need reduces, the pump will reduce its speed. And just out of interest, the relationship between the energy consumed by a pump and a fan and the flow rate is a cubed relationship. So if you have to take the square root. So if you take the flow rate, if you reduce the flow rate by half, you take the square root of that by the amount of energy that you reduce. So it's a massive reduction. So using inverters is a really good idea for pumps and all that sort of thing. CIP, that's cleaning in place, which are systems that are designed specifically for cleaning a process. And they're built in, and they use a specific amount of volume, and they're programmed by computers. Yeah, I'm going to move on. Okay, so reuse and recycle. Actually, this isn't that easy, because you can use cooking water for pets or plants. You can use wash water for toilet flushing. It's quite hard work, actually, and you know, if you're dedicated, you can do it. But to be honest, you're far better off doing all the other things first of all, if you want an easy life. And we all, I certainly want an easy life. Recycle, that's a commercial option really, because it involves cleaning the water to the extent where you can reuse it for a process. So generally it's a commercial option. Disposal. So one of the main things is make sure that as little stormwater as possible is going to the foul sewer. So if you've got an older house with combined drains and you're on the main sewer, then just check out your drains. You can actually request a map of your drains from Northern Ireland Water, and it will show you whether it's a combined drain, a stormwater drain, or a foul sewer drain, what you've got. Also, just have a check around the place just to see if you've got a manhole that you can lift out front. Just put some dyed water. If you, for example, had an extension built on the house, quite often if the people doing it weren't completely switched on, they might have taken your rainwater downpipes into your septic tank feed, for example, which is exactly what I found when I moved into the house that we've lived in for the last 5 years, and 2 years ago I moved all my downpipes so that they went into the correct gullies. And again, you can check, you can just lift a manhole, chalky water or water with a little bit of white paint in it, preferably chalk-based, good for the environment, and that will come down your system and you can see where it's going, check that everything's going in the right place. Minimise the amount of foul water going to the sewer. So that is pretty straightforward. Doing all the things that we talked about, reducing water, will reduce the amount of foul water going to the sewer. Don't flush the loo any more than you have to. It's pretty straightforward. Minimising the amount of solids that go down drains. So there are still houses that have got waste disposal units. Big thing in America, I think, still waste disposal units. Basically, when you use a waste disposal unit, you are knackering the sewage system because you are taking all that organic matter chewing it up, chucking it down into the sewage system and saying, here guys, deal with all this extra biological oxygen demand. So take everything that you can, have one of those little filters in your drain plug, and anything that is organic, put it in your composting bin. Just don't let it go down the drain. If you're a complete purist, you could fit a composting toilet, but I won't be doing that. So commercially, talking about claiming your full non-return to sewer allowance, so this is, obviously I do this talk for businesses, and that means knowing what water is going to steam, so metering your water going to your steam boiler, because obviously all of that water either goes out in steam or goes into product. None of it goes back to drain apart from a tiny bit that goes down, blow down from the boiler. And your product water, got to get all of that. Accurately identify what is foul sewage as against trade effluent, because typically if you get it right and you reduce, you minimise the solids, your trade effluent will almost always be cheaper than foul sewage. Foul sewage is generally one of the most expensive types of effluent to treat. Minimise dirty water going to the water treatment plant, so try and clean everything before it goes there. So in businesses, it's really about making sure that the guys who are doing the wash down are cleaning all the solids out. And then identify how wastewater can become valuable. I did a job for a company that makes a product which they were paying to have disposed of. We put them in touch with an anaerobic digestion plant. It was a valuable source of energy for the anaerobic digestion plant. They now have all of that disposed of for free. And that is the symbiotic circular economy relationship. So anaerobic digestion plants do have a place. Okay, I'm whipping this bit up. Honestly, I'll whiz through the next bit, don't worry. So for commercial, comprehend your water system, make sure you understand what's going where, how, and how much. Eliminate every single bit of waste, non-essential use, all the leaks. Establish KPIs so that you can track from month to month. Continually meter, monitor, and target. That's really, and it's the same for energy actually, so that's why we do all of that. Reuse and recycle where possible. Then consider, once you've driven it down to the minimum possible for your process, then consider alternative water sources, because you don't want to be taking any more than you need to. And only dispose of what's absolutely necessary. Plan, do, check, review. Domestic, turn it off. Various sources of help for businesses, Invest in I Finance, HMRC, water efficient. Now this is slightly out of date, they're not called enhanced capital allowances. There's now the annual investment allowance, which means that at the moment, if for this year and next year, I think I'm right saying, everything that you spend up to £1 million, you can claim full tax relief in the first year. So that's any accountants here? Full writing down allowance in the first year. It's basically a big cash flow aid. And then these two are really good, healthy places to go for advice about this sort of thing, if I haven't put you off it forever. Right, very quickly, Glendun Hydropower. I promised I would talk a bit about hydropower. We're talking about using water to produce energy. It is all about height and flow, because you're using the kinetic energy in the water basically to turn a turbine. That is really what you're doing. The higher you can get, the better. The flow is less important when you've got more height. This picture shows the purple line is the Northern Ireland electricity three-phase grid system. The red line is the Northern Ireland electricity single-phase grid system. Without getting too complicated, you can put a lot more power onto a three-phase system than you can onto a single-phase system, which is why most businesses put in three-phase systems if they can. The biggest cost, one of the biggest costs in developing hydropower is the civil works. So if you're going to be grid connected, which you generally want to be in order to be able to export electricity and earn some money from it, the stuff that you cannot use, then you want to be as close to the grid as possible. So what we're generally looking for is where the grid and rivers and streams intersect. And all these little dots, the red dots which are numbered, which you can hardly see, I'm afraid, are where the rivers and streams intersect. So those, we identified all of those, for this is all in the Glendun Valley. And then these two, which are blue at the end, would require an extension to the grid, so we ignored them because extending the grid is a very expensive option. Then we looked at the catchment and rainfall, number 40, oh yes. This basically gives us each of the locations that we saw in the previous one. This one actually was already had planning permission, and these are the catchment areas for each of those streams. And we worked that out based on, we worked that out, I don't know where it is, but it'll come up, based on the contours of each one. We're then looking at amount of flow, amount of height, and the flow, you create what's called a flow duration curve. So along the bottom is the percentage of time that you have a specific flow, up the side is the amount of flow you have for that time. So typically, for the lowest amount of time, you've got the highest flow because that's when you've got the highest rainfall. And all the streams and rivers in the Glendun catchment area have fisheries protection because they have, I think they're all eels, lampreys, salmon, and therefore there is what's called a hands-off flow, which is set by the Environment Agency. You don't know what that is at the beginning, but typically it's going to be round about 80 to 90%. So that means that at the hands-off flow, you can't use any water. There's 80% hands-off flow. So you can only use the water above that. Oh yeah. Getting the head, which is the height, you'll basically overlay the contours when you're doing an initial feasibility so that you know how far the water is going to travel from the start point to the end point, because that gives you the kinetic energy along with the flow. Then you're using the basic power available, or mass. So this is the basic power available formula, which will give you an initial idea of what you're going to get. This says 57 kilowatt. I think that's pretty high for something, never mind. Then you look at potential generation. What you're doing is you're taking your flow duration curve flows on the percentiles, working out what the residual flow is after you've taken off the stuff you can't use, what goes through the turbine, what's lost in the turbine, the net head, so what's left in terms of height, the turbine efficiency, the generator efficiency, and that then gives you the power available from the power curve for the generator, the number of hours you're going to be generating at each of those points, and that then gives you the amount of energy that you're going to generate in a year based on the flow duration curve. Now this is all based on a theoretical flashy river, because to get this accurately you would need to monitor the flow in the stream or river for a period of at least a year. So this was based on the amount of catchment, and you've got there was a flow monitoring station, I don't know if it's still there, right at the mouth of the river, literally after it's gone under the bridge before it goes into the sea. So we calculate how much we can get. And then we can work out the income. Nylocks don't exist anymore. The key thing is the amount you can use yourself, because if you think that you're paying somewhere between, I don't know, 15 pence a unit, 17 pence a unit for your electricity, then replacing that is really valuable. If you export it onto the grid at the moment, you'll probably get about 5 or 6 pence a unit. So you can see the difference, you know, there's 3 or 4 times the difference in value between export and what you use at home. And bearing in mind that the cost of these things is always high, you end up with long payback times. So what we did is we took each of those sites, the first couple we binned immediately, the second couple we binned because they were they would have to have an extended grid, and then we worked through all those things that you saw, how complicated they were going to be in terms of environmental protection to install, and then what size you could put in each one, what you might earn, what it might cost, what the total cost would be, and what the payback would be. and you can see at the top one, 17.95. Actually, that was for, I think, 1B. Oh yeah, 1B. This was the community scheme that we looked at. But the problem with the community scheme is that you have to get NIE to play ball. And NIE don't want to play ball because you have to have your own private network for that. So that's me done. 1 hour and 5 minutes, so only 5 minutes over the sort of maximum permitted time. If I haven't bored you all to death, has anyone got any questions? Yes.
I'll take this off.
Yeah.
Why is there such... Well, I just moved back to the Northern Ireland from the United States.
Yeah.
And my water was metered there, as everyone.
Yeah.
And I became very conscious of how much water I was using. If I had guests for the weekend or whatever, people on long stay, my water bill would go up. And so you were very conscious of what you were using. What is, and given what you've just said, 75% of Northern Ireland's electricity goes towards water. That's phenomenal. Why is there such reluctance on behalf of the government or governments to implement metering of water? Because water is such a precious resource.
Could I suggest that you write exactly that question to your local MLA and ask them to table the question to the First Minister?
Okay.
Because the reason that we do not have water bills for domestic properties unless they already have a meter fitted is because a political agreement was made, as far as I'm aware, I think I'm right in saying that the political agreement was made as part of the last Stormont agreement to start talks again, that the payment for those would remain on the rates and there would be no individual charges. I think I'm right, but I would definitely, yes.
Well, I would just say that I think it's seen by politicians as political suicide to even suggest such a thing.
Yeah.
And in the South, when it was suggested, the people were out in their thousands on the street protesting. They were not.
Yeah, we're not
water rates.
We're not paying for it at the moment because they just wouldn't pay for it. They just said you must be joking. You made us pay for water in Ireland get lost. And they just didn't pay.
I went to one of the protest meetings organised by people for profits in Ballymena, and for me the thing was, who are we going to pay? You know, I believe, and I think a lot of people believe, that water is part of the global commons, and that companies, investors should not be able to profit. Certainly if you're supplying it to individuals, I can understand in a property society they can profit through all these things that you're describing, the process of other businesses, etc. But for ordinary people drinking and using water, so you might agree to the principle of water metering to be able to control what you use.
Yes.
But who's getting money, you know, that you put in your meter? That's the question.
So I think that if you're going to do this, this is just my personal opinion. I think that water is actually another utility. It's an essential utility, and we have utility companies that produce all our power. We now have, you know, I'm sure you're aware that we're part of the single island network, and that our electricity, a lot of it comes from the south, and even more is going to come from the south. So it's an all-island network, which is one of the issues that might just become difficult in Brexit. But the point about it is that I think that it's perfectly possible to work out a perfectly reasonable deal whereby every household has an amount of water that it can use, and it pays for that. It may be that central government says, okay, we will pay for this first bit, and every bit over that you pay for, that you use, you have to pay for, and you pay an inflated rate. And they'll have to work out ways of doing it where there are going to be some people who have to use more water than others for certain things, but they need to address it, because if they, I mean, Northern Ireland Water have a real problem. Their budget is not going, you know, we're losing, we're paying a fortune to use all this electricity in order to pump this water around the system, and 25% of that, so if we use, it's madness, but we're not giving Northern Ireland Water the money to be able to fix those leaks, because we don't have that money. And Northern Ireland Water is a strange beast because it's part government owned and part, it's neither one thing nor another. And they need to sort it all out and make it a business. It doesn't necessarily, it can be a public business, so that it's owned by the government, but it needs to be a business, and it needs to be run like a business, and it needs to be funded like a business. They need to have the opportunity to be able to borrow the money that they need to be able to fix those things. They need to be able to be, it's all very well having these annual accounts reported, but at the end of the day, if nobody cares about it, nothing's going to happen. 25% of the water is lost in leakage, and they are the biggest electricity user in Northern Ireland. So, it's just, you think about fixing that leakage and think what that does to the usage of electricity in Northern Ireland and the carbon emissions it saves. It's just madness not to do it.
They have a domestic allowance already, and if people have are paying, businesses are paying water rates, they will get a reduction of the domestic allowance if there's a house coming off as well.
They do.
So, I mean, the figures are all there. They've done the something already.
Yep.
It's not as if it's a complicated or, we're into our own territory. This is stuff they know.
No, it's pretty straightforward. I mean, it is, I think you'll find, and I very happy to be corrected, that this is a political issue.
It is.
And rather than what it should be, which is an environmental issue.
And I think
With
it's also
they found in Britain when they, not long after, they had nationalised the essential power and water, etc. And the reason why it became such a difficult area was because you had the government making cuts on people, cutting public services, massive cuts being operated, wages being cut by the power companies, but they were voting their directors increases of like 9 and 15% a year. And people just thought, what is this?
Well, of course, the other thing that
utility, you're just giving it to a few people.
But the other thing you have to bear in mind is, if you think about what happened in the west of Ireland only 5 years ago, maybe not even 5 years ago, where they built a new wastewater plant, a new water treatment plant, because the old plant was not good enough to prevent bacteria getting through. They cocked up the build, and they ended up putting all the water through both treatment plant, through the old treatment. Anyway, there were people in Galway boiling their water for months while they sorted this problem out. And all I would say to you is that, don't count on the fact that you're going to have good, clean, potable water all the time if you don't put the investment into Northern Ireland Water. Now, I'm not Northern Ireland Water's greatest fan, and I should declare that one of my colleagues in my business is a consultant to Northern Ireland Water on their energy side, which may be one of the reasons I know a bit about it. But the reality is that we need to invest in that infrastructure. We've already, energy is the big buzzword. Water is waiting just around the corner.
I think also it's the population, and how often I'm sure we've all heard people say, well, water is free. And I think the government could do something to inform.
Well, they could do this.
To inform them to say,
it's
well,
not
actually,
rocket science.
this is not free.
Yeah.
It's very expensive. And globally, I mean, the number of pieces I've read in the last decade or so about water wars of the future, this is what we're looking at globally. So it's not just the micro here, but on a global scale.
Well, Egypt and Sudan
is an effort to privatise water. But it's not just water, it's food that they want control of as well. I think Mr. Nestle was famous for trying to actually hoard all the water in his local area and hide it under his mansion. Now, I didn't realise we were here to discuss lethargy within the Northern Irish government, but having studied at CAFRA, where we were informed that Northern Ireland is actually like a wild, wild west. It takes light years for anything to sort of go through the bureaucracy, and they've actually taken, I think they've had the last 6-12 months off on full salary. I suppose the only other comments I would make is that I feel a big proportion of water wastage was due to toilets. We should not let squeamishness deter us from discussing the benefits of compost toilets. And just to reiterate, any working class person I've spoken to would be dead against the privatisation of water. They've enough bills to pay as it is.
I suppose it's the difference between the principle of paying for it and privatising it. I think people wouldn't resent paying for it, provided there was a line that you described as long as that money wasn't just going to make. I don't think it should be possible.
Absolutely. You know, they've done all this work, they know how to do it, they just need the political will to do it. Actually.
And if people understand, I mean, if the garden hose is leaking and you leave it on, you go, it's just leaking. But if you suddenly realize, well, actually, I'm paying £1.50, where it makes you think differently about the resource.
Yep.
Can we answer one totally different question? It's about the treatment of the sewage, because we live by the seaside.
Yep.
And I always wonder what happens to our sewage. What is our sewage here treated before it goes into the sea? Do you know? Or you know, as a percentage?
So some of it, so it gets treated, and an awful lot of it goes into waterways, but it's well treated before it goes into the waterways. There were, although I don't, the issue is, remember when I mentioned the where you've got combined sewers and you've got stormwater flowing into, that's where the issue arises. So basically what happens is that if the wastewater treatment plant is flooded with a big amount of stormwater, it cannot cope. So when you're treating something, it's actually for treating wastewater, it's a time process. So you need to get the oxygen in, and you need to give the bacteria time to do their process. And typically, the best way of doing that is having a holding tank where you mix your wastewater so you get a blended level which stays fairly average, which then makes it relatively easy to treat the wastewater because you know how much oxygen you've got to put in, what you've got to do to it. The problem you have is as soon as you get a really heavy rainfall event where you've got these combined sewers or you've got a stormwater drain coming down into a wastewater treatment plant, it floods it. And when it floods it, you get your sewage overflowing and coming down wherever that outfall is. And I know they had a problem. I think the last time it was on the news that I saw, it was on Newcastle Beach. There was one up there somewhere. Anyway, yeah.
But the EU was ready to take an infraction proceeding against the United Kingdom for the condition of the Ballyvoy sewage plants.
Yeah.
And they've both been upgraded. Ballyvoy new sewage plant cost over £1 million to upgrade. So it gives an idea of just what the capital cost is, the running cost is something else on top of that. And that's for a tiny segment. Ballyvoy was millions of pounds. Because there was still a lot of raw sewage going in with the old plant.
To be fair, I know that Northern Ireland Water have done a lot of work on their sewage treatment plants, and they've made huge steps forwards in their carbon emissions, and they are reducing and heading these down all the time, and they've brought in a lot more renewable energy to try and deal with things. You know, they have an old infrastructure. I mean, we will all remember when we had that terrible winter where all the pipes exploded. But I remember drinking troughs in fields with taps left on to try and stop the pipes from freezing. Yeah. And that was completely counterintuitive to the whole problem.
So just one point, go back to the United States in a way, and that is that at least we have central control of water supplies in this country.
Yes.
The States, the landowner has all the rights to the water under his land,
yes,
as I understand it. And the result has been that aquifers in Texas and other places have been completely empty to irrigate crops. And what were fertile areas have randomly turned into dust bowls as a result. And people have actually, farming has ceased, people have had to move out because there's no water. That's and what was a communal asset, the water supply, has all disappeared.
So we are fortunate.
I think the area on the Hammond Aquifer, usually one of the largest aquifers just south of Great Lakes, so that was not an issue there.
No, right, but certainly, I mean, in Texas, which is
the
farmers were pumping it out to irrigate their crops, and the area that could be cropped just contracted year on year until it was down to a couple of farms in the middle, and that was it. And that is, what the Treasury of the Commons, the perception that it's actually a common property, if you like, it is exploited by individuals for themselves. And I think at least we don't have that, but we do need to control better the price and the way in which water is used.
I think, and we actually, so we thought that we didn't have that much water. We thought we were depleting our aquifers a few years ago, but GSN, Geological Survey of Northern Ireland, have done a lot of work. There was a publicly funded rural borehole scheme a few years ago, which involved doing quite a lot of boreholes into basalt and the lower basalt formation, and they actually discovered that there was a lot more water in the aquifers than they thought. So we're well off in terms of aquifer, and we get good recharge. We've got quite a lot of superficial aquifers. So down in the direction of sort of Strabane, that sort of area, there's some pretty good superficial aquifers where it's sitting underground. The difficulty is with superficial aquifers is pollution. Because the moment you open a hole into that aquifer, you're effectively opening a route for pollution.
I think, if I remember correctly, Patrick, I wasn't here, you were talking still online, that you mentioned Loch Ness, which I always thought was this incredible resource. But I think you said something that there's so much running off into Loch Ness that it costs Northern Ireland Water a fortune to clean it.
That's where a huge amount of their energy is going, is to clean the water.
Yeah. They had a real problem, and they've got a problem with, there are an awful lot of old septic tanks in Northern Ireland, which it's another problem that's never been addressed really, and it's getting better. But old septic tanks, what tends to happen? So with a septic tank, you've basically got the tank, which is just a holding tank with a baffle in it generally, and then you have what's called, normally you have this infiltration field, and the problem is that a lot of these septic tanks are put in areas that were boggy, and that means that they can't. This water is meant to have its secondary treatment cleaning by running through the ground. But if you put it in a boggy area, it can't infiltrate, and it just stagnates. And you end up with this water ending up running off into waterways, and it's going to end up in Loch Ness if it's anywhere near the centre.
There's also huge amounts of agricultural nitrogen and phosphate that are going in that have to be removed.
So I talk about the fish kills because I live in a house that has a river very close to it, and every year, funnily enough, except this year, every year there has been a fish kill in that river. And that fish kill happens, I see it outside my house, and it happens immediately after a period of dry weather. So what happens is, very dry weather, the river's quite short, quite flashy, so it rises and falls quickly, water level goes down, while it's dry, there's various nasty things accumulating in the shucks and in the drains. As soon as you get a heavy rainfall, you get this first flush runoff, and that just goes straight into the river, drags all the oxygen out, kills all the fish and a lot of the plants and the biodiversity. It's not rocket science, it's about education. Please, can I go now?